part 2 of your lesson on parametric differentiation. We're just going to go through some answers. So, first of all, for your practice questions, there are your answers. Generally, leave them as a fraction, don't try and be fancy. It's fine if you have cos over sine, but in that case, you would tend to change it to cot. Okay, but there you go, there's the answers for practice questions 1. Now this application, so first of all, the table of values, and I forgot and left this animation in, but you're just plugging the numbers for t into your equations for x and y and getting out pairs of coordinates. So if you didn't have a calculator, you would plot those coordinates, and then you do. So use your calculator to help you sketch the curve. So that's what your sketch should look like, and that's what you need to have copied into your notes. The coordinate of the turning point, so you would work out dx by dt and dy by dt. There's dy by dx. We want to know when that equals 0, so t equals a half is a stationary value. We then need to put that into the equations for x and y to get out the coordinate. Okay, so x is 1/8 and y is -1/4. So what's going on when t equals 0? So we get the coordinate 0, 0, and dy by dx has a value of dx by dt equals 0. If we just go back there, dx by dt is 3t squared, so when t equals 0, dx by dt also equals 0. So that's not allowed. So dy by dx is infinite. So as t tends towards 0, dy by dx tends towards infinity. The y-axis is a tangent, or the line x equals 0 is a tangent to the curve at that point, is what I will allow. Please never write that is infinite, because it makes me a bit ugh. Anyway. So there's the application. That is what's going on when t equals 0. You had these practice questions. Some of them had some quite tricky differentiation in, as you saw from part A. There are the answers, and all of your answers should be exact. That means I would like to see this is a square root, I'd like to see these as fractions, I'd like to see this with pi involved, please. So make sure that you, if you didn't have those answers, make sure that you understand that when it tells you the answer is exact, that's the format that we're looking for. Okay? This one, parametric differentiation, I'm just going to talk you through it. So we get dx by d theta, dy by d theta, and then we combine them to get dy by dx. You're told the value of theta is pi over 6, so you plug that in to the expression that you've got for dy by dx to get out this. Leave everything exact, everything in terms of surds, so you end up with this gradient. Flip it up, make it like reverse the sign to get the gradient of the normal. And at that point P, theta is pi over 6, so you have to put that into your equations that you've been given for x and y. So you get those values for x and y there, and then you do y minus the value for y equals m, x minus the value for x, and then in this case they've made there be no denominators. Okay, right, so that's that. This exam question I'm going to go through just so that you can, I thought it was useful to see my working. So we've got x and y there. So you've got dx by dt. There we go, smoothed it out a bit there. So dx by dt, a fairly straightforward differentiation of sine. Dy by dt. Oh, notice that I changed y into index form like that already from the squared in the middle, because you're differentiating it. It's almost, I think it's easier to apply the chain rule like that. Anyway, apply the chain rule, bring the power down, reduce the power by 1, multiply by the differential of what's inside the brackets. You end up with minus 8 cos t sine t. So, it's quite nice because it's a show that question. So the other thing that should leap out at you is that you've got cos of 2t and cos of t sine of t here. You're obviously going to have to use an identity, one of the double angle formulas. So we're going to turn the top into like sine of 2t, basically. That's the way we want to go, because we know we're aiming for tan, we know we want there to be sine over cos, and we know the final answer is 2t as well. So that's why we kind of know that we're going to use that identity. So last thing I'm doing is I'm just faffing on with this fraction a little bit. I appreciate that you would just use your calculators for that, so that's fine. Also, apologies, I've forgotten a root 3 here. It's coming in a second. So I've written out dy by dx. I've got negative 2 over 3 root 3 sine of 2t, or sorry, tan of 2t in the end. And there, look, I've realised that I missed out my root 3 is coming in. Okay, so that's part A. Your constant k is that negative 2 over 3. And then for part B, we need the equation of the tangent at the point where t equals pi over 3. So we need to use that t equals pi over 3 to get what x is by plugging it into the equation for x here, to get what y is by plugging it into the equation for y, and to get what m is, so it's the equation of a tangent, so we plug it into our dy by dx. It's not a normal, we don't have to do anything else, so we get that gradient of the tangent. Notice that you can do part B without part A, so even if part A sort of everything falls apart, part B is still accessible, and there's going to be questions like that at A level where that's very true. Okay, so be aware that you don't need to panic if part A has, if you just haven't shown that, use what the question's given you and do part B. Okay, and there you go, you've got y equals 2x minus 2. Now there's the mark scheme for you, so you can pause now, you can see what marks you would get if you didn't get all of the working for it. And your practice for this topic is to do questions 5 through 11 on exercise 9G, and that's that. Parametric differentiation, it's a wrap.